So cool. Now that we finished up probably the most difficult part of this video, I'm glad to say we can move on to something a little bit more fun and less intense. What I want to do now is I would like to create the hitbox for Link's sword for the enemy and the health components for both Link and the enemy, so we can actually have some kind of gameplay. Let's go into component.js and create these two components, and then we'll have them interact with the systems that they need to interact with. Scroll to the bottom. Let's create class health component, extends component, and it will follow the pattern that we always have. Component type. And for our health component, I think that I'm going to want to have 3 different things attached to it. The first property in our health component, I think it would be best to have it as the total health. And let's also add this into the constructor. I did not forget it. So this is the amount of health an enemy or Link has. Now, we also want to keep track of how much remaining health they have. Component object. And the last thing that I thought about in advance is there's going to be a time when Link is hit by an enemy or an enemy is hit by Link, and they cannot be attacked a second time for a limited period of time. So it's going to be like a few invulnerability frames. If you've ever played a video game, I'm sure you're familiar with that feature. So let's do this invulnerable time, and we'll set it to 0 to begin. And I'll show you how we're going to use this in a little bit. I'm going to export it, health component. The second thing I'm going to create is the hitbox component. And we're going to follow this pattern as well. Do the super. And what we're going to attach to the hitbox are 2 properties. The first thing is going to be the owner. So when Link swings his sword, for example, it's going to have a hitbox attached to it. However, we don't want this hitbox to hurt Link if there is an overlap. So we need to be able to designate what entity owns it so we know what the target is. So this owner is equal to component object.owner. This is followed also by the amount of damage that the attack is supposed to do. So if Link has multiple swords through the game, which he does, each sword being progressively stronger, we want to make sure we don't do the same damage for different swords. So we should have a damage property attached to each one. And let's export this. So in order to test this out, the first thing that I do want to do is I want to add a hitbox to Link's sword. Let's go into the render system where the sword is created. And let's add a hitbox dummy component here. So we can create or add hitbox. So const dummy hitbox component. Name hitbox value. Damage, and we'll just set it to 1. And now to the owner, you can designate the owner in a lot of different ways. Different systems will use enums, other systems will use constants. To keep it very simple, there's only 2 real owners of hitboxes in this game. There is Link and there are enemies. Enemy attacks cannot hurt other enemies, so we don't need to keep track of the origin of hitboxes because there is no friendly fire for these enemies. So for Link, why don't we just set this as owner set to 1, and then we can have enemies just be 2. So let me actually even make this note. I think that is a good way to do it for our purposes. Link is equal to 1, enemy is equal to 2. And I know later on we will have projectile, and we may want to differentiate between those two things. So why don't we do enemy projectiles equal to 4? We'll use even numbers for hostile hitboxes. And we'll do that because it's very easy to determine if a number is an even number or not. So cool, we have this. And now all we need to do is just pass it in here. Very nice. And to test this as well, why don't we add this into our debug code? And we can come here and why don't we check? We'll do const hitbox. We'll try to pull it out. Entity components. Right, because it is an entity that's coming in here. And if there is a hitbox, why don't we do crect of x, y, width, height. C line width. Set it to, and we'll set the stroke style to, let's set it to orange. And at the end of all of this, we actually need to call stroke twice. And begin path on each one of these. That way one line width or one stroke style does not overwrite the other stroke style. And now that we have that set up, we do need to add this into the registry before we get ahead of ourselves. We need to tell our registry how to recognize this, so we can just add it in here like so. So case hitbox const object, the new entity components hitbox will be equal to new hitbox component object, add a break. Okay, now and let's check, make sure it works. I'll save my files, even though I think I did. Okay. He grabs the sword. Turn on the debug. Fantastic. It's a little bit bigger than we'd probably want it to be. But that's fine for right now. We can reduce the height and width a little bit later. Next, let's add the health component to our registry and then add it to the player and then to the enemy, and we'll have these hitbox and health components interact with one another. So let's add it in here. Health component object is equal to component value. New entity components, health, new health component. Cool. So when we create the player, create player, let's make sure that they get a health component as well. So it's these two properties need to be present. So const health, const dummy health component is equal to name health. Just make sure, yeah, health value. And the two values that there will be our total health for Link will be, let's just say it's three hearts. We'll operate on a scale of 0.5 because Link does lose health by half a heart. So we'll just use 3 hearts as his total health. And we'll also add for the remaining health, we'll just add 2.5 for right now. We'll add this in, dummy health component. Very nice. And then for the enemies, or our one enemy at the moment, we can, well, really, we can just do this. We can just copy this and go to enemy. Copy paste that, and we can just make the remaining health 2, because he's not going to be able to recover health at the moment. So that's fine. Dummy health component. So now that we finished that part, we should create some kind of system that can reduce the health of an entity if it's hit by a hitbox that's not friendly to it. So let's go back again into systems. And we can create a new system. Let me collapse some of these. Put it next to transit system. We'll just call this hitbox system. It'll follow the patterns that we're used to using. With a component requirement. This component requirement is equal to hitbox. And I think position is another good component, though that should also be included, because if there is no position on a hitbox, it makes it a little bit difficult to calculate the overlap between hitboxes and other entities. And speaking of which, that is what we will be doing, and for that reason I put it right next to the transition system. We're going to be essentially, again, copying this information to determine if there are overlaps between entities that have hitboxes and entities that have health. So for let I equals entities.length I plus plus. Actually, let's do this one in reverse. We're going to be looping through the array of entities from both directions. So while I is greater than 0, or rather I be the negative one, and then j can be the normal for loop. J is less than, well, j is less than I. I think that logic works, because once I and j pass each other, I believe every combination has been checked. So let's get both of the possible entities. So entity I, this entity's I. Ooh. And why don't we actually just call this E1 const E2 entities J. And we're going to start off by just getting the positions of these entities. So const position E1 position E1 dot components const position E2 position E2 components. And all we want to do is see if they overlap. That's the first thing we're going to do to handle this. And we can set this as, we also need to pull out the x and y's, of course, and the widths of each one. So x equals E1x. Let's just use it as numbers like that. Y, 1, Y. Width, or 1 width. Height, 1 height is equal to E1 position. Oh. Sorry, I just realized I cannot start a variable with a number in JavaScript, which is cardinal rule. There we go. Just duplicate that, change this all to 2. Great, okay. So we'll take P as the first entity and E as the second entity. So if x1 is less than x2, then it's plus width 2. X1 plus width 1 is greater than x2, then if entity y1 is less than y2 and height 2, so if there is an overlap, let's just console.log out overlap. And we're going to test this now by having the sword overlap with the enemy. What I would like to do is just give Link the sword immediately. It makes it a lot easier. So copy this line, go into animations.js to the Link pickup sword. Copy this line. Let's just paste it in somewhere for the player. So how about on the load screen function, just at the bottom. Or actually, even at the create player. That's a better place to put it, actually. We'll just have it right here. Make sure sword 1 is imported. Save it. Player is not defined. 231. Index. It's because I did not add this to it. Yeah. And also, let's just load up the last screen that has the enemy on it. So we'll take him out of the shop and we'll put him in screen E. And the last thing is we should add a hitbox onto our enemy, of course. So when we create him, let's add this hitbox. So const dummy hitbox component. And remember, I said the owner should be an even number too, and we'll do damage. We'll just set that to 0.5. And let's pass it in, dummy hitbox. Let's go into our system because I just realized we did not export it. So let's make sure we export it and also have our registry detect the system. And then we'll add it in through the index, and I think we'll be good to go after that to test this out for real. New system, new hitbox system, system type, break, and then in our index we can add the system. So this registry add system, hitbox system, and let's call the update function just like we're calling all the other systems. It's been a while since we added a system. So this, you know what, let me put this animation, collision, movement, transition, actionable. This can go above transition and actionable. This registry get system hitbox system update. And do we need anything? No, not at the moment, it seems. Cool. So let's check this out. I think we're good. Okay, so both of the hitboxes are there. Now, if the hitboxes are overlapping, we should see some console.logs, and we are. So it's properly overlapping. Very good. So we're going to handle a few different situations. The first situation is if Link's sword overlaps with the enemy, do damage to enemy. If enemy overlaps with Link, do damage to Link. if enemy projectile overlaps with link, will do damage to link. Let's handle the first situation. So we need to do a little bit of complex logic here since we're dealing with two different hitboxes. So we first want to ask ourselves, or actually let's get the hitboxes. That's probably the best thing we should do. So now let's do const hitbox. We'll set this to as hitbox 1 E1 components const hitbox 2 is equal to E2 components. Cool. So we're going to ask ourselves who the owners are. So if hitbox1.owner, and let's pull up components so we can take a look at this. So if it is equal, I'm going to add link sword in here as well. Link sword or link weapon is fine. That's fine. We'll set it to 3. So if hitbox owner is 3, if hitbox 1 owner is link weapon, and hitbox 2 owner is enemy, then we do the damage. And hitbox 2 owner is equal to 2. So that's the first possible situation. However, we don't know if hitbox 1 will always belong to link's weapon. It could be the inverse. So it could be possible that hitbox owner 2 is actually link's weapon and hitbox owner 1 is the enemy. So we need to add an or statement here. So we're going to group that together. We're going to add an or, and it'll just be the inverse. So if the owner is equal to 2 and hitbox 2 owner is equal to 3, then I'm going to flip this is enemy is link weapon. Cool. Then we'll do damage to the enemy. Fantastic. Okay. So that's the first possibility. So our second possibility is if enemy overlaps with link, do damage to link. How are we going to do this? Well, currently we can't really target link because he does not have a hitbox. So why don't we just add a hitbox to link? Create player. Const dummy hitbox component. Name health. Value owner. And we're going to set this to 1. And the damage is going to be undefined because link can't really do damage. By contact, at least. Perfect. Okay. So now we can interact with him like that. So let's do an if-else statement. So if hitbox 1 owner is equal to 1 and hitbox 2 owner is equal to 2, we'll do damage to link, right? However, again, like the previous example I gave you, it's possible that hitbox 2 is actually link and hitbox 1 is the enemy. So we're going to do an or statement. Hitbox 1 owner is equal to 2 and hitbox 2 owner is equal to 1. Fantastic. So we have this for the enemy overlapping with link. And finally, we have if an enemy projectile overlaps to link. Interestingly enough, in this game, we're not really going to be handling the overlap of a projectile and the overlap of an enemy differently from one another. So what we could probably just do, I think, is simply use the modulus operator to determine if one of the hitboxes is even. I remember I mentioned here that since it's 2 and 4, we can just easily determine that. I was doing that with this scenario in mind. So instead of it being equal Why don't we just do modulus? Oh, so modulus 2 is equal to 0. Modulus 2 is equal to 0. And just like that, we've simplified the logic structure. So now let's handle these two possibilities, and we'll start with the link sword overlapping with his enemy. So we'll set it as a constant. So if hitbox1.owner is equal to 3, then entity 1 must be link's attack, else it must be entity 2. Then on the flip side of that, we can go if enemy, or we'll set a variable as enemy. So if hitbox1.owner is equal to 2, we set it to E1 else E2. So in that way, we should be getting the proper entity for both link attack and for enemy. Now what I'm going to do is I'm going to get the damage from link attack dot components dot hitbox. Since remember, this was coming from the entity itself. Okay. And we're going to just check to see if damage exists. Although it should always, in the cases we're using it for, I'm going to just add this if statement to make sure. Because perhaps in the future we'll have, or you could have the boomerang, which doesn't do damage but freezes the enemy, right? And if it does have damage, we want to injure the enemy. However, we only want to injure the enemy if the invulnerability time is equal to 0. So I'm going to show you how this is going to work right now. So const invulnerability time, enemy components, hitbox. If invulnerability time is equal to 0, then we can do damage. So very simply do damage. And as a little preview, apply hitback or knockback. We'll be doing knockback things in a little bit. But right now, we'll just do damage. So we'll actually get remaining health as well. Or you know what? No, we'll keep it like that. Enemy, components, health, remaining health. Right, because we have it in our health component, and we're going to subtract it by, or we're going to decrement it by the damage. And we're also going to set the invul time to, we'll set it to half a second. Cool. We will be handling this later. So we're going to come back to this value in a bit, but just stick with me for now. Let's handle if enemy overlaps with link, do damage to link. So within this if else, we can take these values and we're going to tweak them just a bit. So this is going to be link. And this is going to be enemy or enemy projectile. But that doesn't really matter. And we can say if it's equal to 1, if hitbox owner is equal to 1, it's entity 1, else entity 2. And just let's do the inverse of that here. So we're going to do something similar. We're going to get the damage, but this time we're going to get the damage from the enemy, not from link. And we're going to check if there is damage, do something. And just like up here, we're going to check the invulnerability time as well. Although we're going to be checking it from link And we're going to ask ourselves if invulnerability time is equal to 0, then do damage. And we can do link components health remaining health minus damage, and we will set link components health invulnerability time equal to 500. Okay. So great. Now we have these values. It's fantastic. But an issue that we are having is once this is set to 500, how do we alter this to make it go back to 0? Well, what I actually am going to do is I'm going to create a health system which will monitor the unit's health, the entity's health, and also remove entities that should be dead. And I also just am realizing now it needs to be 500 plus date now, because we're tracking when in time this occurred. Okay. So I can even go right below. I'm going to make it a little bit smaller. Get rid of this console.log. Okay. I'm going to make class health system extends system. Constructor system type super system type. This component's requirements, we'll just set this to health. Update. And for this update function, I just mentioned that it would be monitoring units health and would be removing the entity's health, and it would be removing the entities who no longer had any health. In order to remove entities, we will need the registry at some point, like that. So now let's make our for loop. And first off, let's handle the invulnerability time, remaining health invulnerability time. Let's get the entity. Const entity is equal to this entities.i. Great. Entity. So if date now is greater than or equal to invulnerability time, then let's set the invulnerability time back to 0. That's the first thing we're going to handle. Now, if remaining health is less than or equal to 0, we need to remove it. So very simply, let's just do registry entities to be removed, push entity. And that's all that I think we need at the moment for the system. Let's add it to the exports. And in registry, let's go and add a case for this. New system equals new system type break. And then let's go into index.js and let's add this system. And we can put this at the bottom, or actually let's not put this at the bottom of priorities. Let's do this right after hitbox. Get system health system update, and we'll pass this registry. Cool, everything looks good. Oh, except this. That should be hitbox. Let me go through these systems as well. System. Oh, that should be health. That should also be health. and that should be components.health dot components bracket health. Just a quick double check. And this should be 3. We didn't make any changes to animation component for this, so let's check out. I think that's good. We can probably check out what we got. Let's see. Okay, cool. 1, 2. Nice. It killed him pretty quickly, but we only said half a second. Let's watch. Oh, and Link got killed as well, too. Fantastic. My screen went out for just a second. Unfortunately, my camera got disconnected. Nothing. I didn't do anything, luckily, other than just closing out these screens to leave index.js open. And I was doing that in preparation for the inventory, which we will be altering now. Because before we get to knockback, we want to be able to see how much health Link has, just like we do in the game. So why don't we go into inventory and begin this? Let's see. This is handle pause animation. And right here, why don't we render Link health? So in our assets folder, we actually already have the PNG files we need to display. So if we go here, we can see that there is full heart, half heart, and empty heart PNG files. And we can just pull that up here just to look at it very quickly. And half heart. And why don't we get all of these images? So this full heart, this half heart, and this empty heart. New image. And right here we can set these values just like we set the other ones. Full heart.png. Half. Empty. Half. Empty. That corresponds properly to each of their names. Very good. So now that we have those images set up, let's handle the rendering. So in here, if, and we'll set it up just like we did before with the player. If player.components health, let's pull out the, what was it? The total health. That's right. The total health and the remaining health from player.components bracket health. And what we're going to do now is we need to think about how the health is set up. We know that there are essentially 3 kinds of values that are displayed, right? There is the empty heart, the full heart, and the half heart. And we need to differentiate which heart will be displaying based on how much health the player currently has. And the way I thought about going about this would be to push into an array of health. Let's just call it const array health. A value for which heart it would be. So for example, if it's empty, or let's say it's full, it would be 1. If it's half, it'll be 0.0. And if it's an empty heart we need to display, it will be just 0. So full, half, empty. And how we would go about filling up this array would look something like for let I is equal to 0. While I is less than total health, we'll increment I. And if the current health is greater than or equal to I plus 1, we'll set this array of health equal to 1. Then we'll just do current health less than equal to I plus 0.5, right? Array health I is equal to 0.5. Else array health I is equal to 0. Full heart, half heart, empty heart. And once we have that, we'll be ready to render the hearts onto the screen. Now we need to have a good idea of where we should place them. I have a feeling that it'll be located at these values, but we'll test it and see. 150. We could just set the width to 40 and the height to 20. Let me just spell out width to keep in line with how we've been doing it before. These are just starting values. We may need to change X, Y, width, height. We'll see how that goes. And now let's try to render these hearts. So render hearts. And we're going to go loop through the array health. And we also need to keep in mind that after we render one heart, we need to move the next heart to the right of it. So why don't we just move it over very slightly by a factor of 15 maybe. We'll see how that overlaps. And if array health I is equal to 1, then we're going to do... And actually, you know what we could do? We could say let target equal to undefined, target equal to this full heart, right? Else, if array health dot I is equal to 0.5, target is equal to this half heart, followed up with an else of target equal to this empty heart. And finally, let's just use the context to draw the image. So target. Now let's set the destination to be x plus cox, y, and we'll do width, height. Oh, and we have to put it inside the for loop as well. There we go. Oh, and also let's change this. Sorry, I meant to say remaining health. There we go. Okay, very good. Just a quick check. That looks good. I did forget the source. There we go. Okay, let's see what it looks like, if it's appearing. Okay, it is not appearing. I just think that's probably due to something being wrong with the X or the Y. Let's just reduce it to, let's reduce Y first. We'll just change it to this sword Y just to make sure that we're getting the Y properly done. Okay, and that looks pretty good. So we're getting the hearts now. I can just open it up like that. And I can play around with the values a little bit. Why don't I make this much smaller? And we'll make it like that. Oop. The hearts look a little bit better. And also, if you're looking, you see that the health goes down when the enemy was attacking us, which is good. So it's representing that properly. Cool. But we probably want to move it over a little bit to the left. Maybe move it down by a few pixels. Cool. Maybe not make it as big. 13 by 13. I like how that looks right now. Boom, and he's dead. Maybe make it 14. Very cool. So our rendering hearts is working properly. Very nice. And the damage that's done by the enemy, we see it graphically. And knockback is a bit of a tricky thing to implement. Let's add, and I'll pull this up side by side. Let's add in our movement component some properties for knockback. So this knockback Vx will be set to 0. This knockback Vy will also be set to 0. We're going to be altering these properties and applying them to the entity's movement. But before we do that, we need to write an algorithm essentially to determine the knockback. And how we determine the knockback is by figuring out, first off, what side is the collision occurring on. And we'll do this by setting up flags or passing values up out of these if statements. So I'm going to create, let's see, right here, const knockback. We'll just do KB receiver const KB, and we'll have to actually set that to let, just because we will be setting these values. KB sender undefined. And what's going to happen is I'm going to, let's see, in this one, oh, we can actually pull this out even further. We need to put it up here. There we go. What's going to happen is we are going to set the receiver to enemy and the sender to link attack. And down here, we're going to do the receiver to link and the sender to the enemy. We can collapse this logic structure. Okay. So what's going to happen is a little complex, but it's all just basic arithmetic, but just a lot of logical thinking. So what we're going to do to determine the direction is we're going to get both the centers of the knockback receiver, the center X, Y, the center of the entity at the X axis, and the center of the entity at the Y axis for both the receiver and the sender. So we're going to get the difference of the X and the difference of the Y, and then we'll be able to just figure out the collision direction. So let me show you what I mean. So let's do const KB receiver, or let's just write receiver. Let's do receiver X is equal to KB receiver components dot position, and we're going to get the X value, and we're going to just subtract it from the KB receiver dot components position width divided by 2. So this is actually let me write this down. Receiver center X. We can copy this for the Y. Dot Y. Height. And then let's get the sender center X. So KB sender dot components position dot X. So very similar. Minus KB sender components position dot width divided by 2. Now let's get the y. And we'll just change this to receiver. Right? Okay. And we need to make this capital. I'm going to make this a little bit bigger. Receiver, center. This needs to, this needs to be sender. Oops. Sender. And then we're going to get the difference between the two. So let's do difference x is equal to receiver center x minus sender center x. Let difference y equal receiver center y minus sender center y. So what's going to happen now is we actually need to create absolute differences, absolute diff x and absolute diff y. And that is going to tell us what plane, the x or the y axis, that the collision was on. So we're going to, you know what, we can actually just take this and we'll just say if difference x is less than 0, just do different x times -1, else just set it to different x. That's actually the best way to do it with the ternary operator. It's less than 0, difference y times -1, difference y. Oh, and that is it. There we go. Okay. So, as I said, whatever is greater will determine the axis that the collision occurred on. So if absolute diff x is greater than absolute diff y, this means it is either left or right. Else, it is either top or bottom. So now we just need to determine, we'll take the left or the right approach first. Now we just need to determine what side the collision is on. So if the difference of x is less than 0, so it's negative, okay? The side, that means it will be coming from the right side. And let me just set let side equal to undefined above. And apply knockback, okay? We won't do that quite yet, but just 1 second. Else side equals left. And then on the flip side, or I should say in this else statement, if the difference y is less than 0, that means the side it's coming from must be the bottom. Else side equals top. Okay. And actually, wait, I got this wrong. Okay, let's also wrap this in an if statement because we do need both of these things to be defined or else there will be an error that's thrown. We could just put it right into the brackets here. Let's go through this. X to X width, Y to Y, height, XX width, Y. Okay, that's not right. That should be Y. That should be height. Okay. And actually, you know what? It's supposed to be inverse. My bad. My bad. Looks better. Looks good. Good. Okay. So if this works properly, what should happen is there will be a console log of the side that the impact came from. So let's go to Brave. Oh, well, we saw that there was already something. Let's reload this and see. Okay. Oh. Top. Okay, that worked properly. Let's check the other side. Left. Now it should be bottom. Bottom. Oh, I died. And let's just make sure right is working. Right, perfect. Okay, so that looks good. It's properly detecting the side that the collision's occurring on. And now, what do we do once there's a collision? Well, we need to apply knockback to the entity. So let's apply the proper knockback. So we'll take the receiver, KB receiver, knockback receiver, components, movement. And if he's getting knocked back to the right, why don't we apply, how did I name it? Knockback. Let me go into the components. Let's see what I named it. I think I named it knockback VX. Yes, knockback VX. Knockback VX. And we'll minus it by 10. And then for the other direction, let's just do the opposite. So knockback VX. And we actually should, yeah, we could actually set it to -10. That's fine. We'll set this to 10. And I'm just setting these values right now. We don't need to keep it like this, obviously. We can change the knockback if it's too fast or it's too slow. I have a feeling that it will be plenty fast enough, though. Movement, knockback, VY. We set this to 10. And then we will come down here and set this to -10. Cool, and once this is done, we should get these values. But while we're in here, why don't we set the audio clip to play? So why don't we go in here if this is an enemy, and we'll set the audio to play if an enemy is hurt. So if enemy overlaps with Link, do damage to Link. Oh, wait. Oh, this is for Link getting injured, but that's fine. We can do that as well. So new audio, and I believe that'll just be from this point. I think it's just assets, audio, Link hurt. Put this down here as well. And we'll copy this. And we can paste it down here, but instead of Link hurt, we have an audio file called enemy hurt. And we can put it right here. And let's just not forget to do play. And let's make the invulnerability slightly longer so it's not so fast. I made it 1.5 seconds. Now let's try out our sound. Let's see. Okay, Link just got hurt. I was able to slice the bad guy. Cool. So that works. Sound is working properly. And also, while we're on this topic, you know what? Let's add the sword slash sound as well. I was putting this one off because it wasn't as important, but now that we're finally doing this, why don't we add the sword slash sound right here? New audio, assets audio, and I have sword slash right here. Play. And finally, let's pull this all together and go into the movement system to implement the knockback. So let's go to movement system. Boom. So there's two primary things that we need to handle in this movement system. There is the application of the knockback, meaning it actually affecting our velocity and then affecting the user's position. And we need to also implement the idea of friction, really, because as we had seen, we applied a value of 10 to the knockback, but it'll just constantly be 10. So Link will presumably have this knockback value affecting his position the whole entire time. And we don't want this. Now, currently, you can handle physics simulations in many different ways, but because this game isn't very complex when it comes to physics, we can actually just handle this by using a friction coefficient and reducing the value of the velocity by this coefficient. So the first thing that we'll do is we'll just have this affect the position. So we'll add it, movement, knockback Vx, movement, knockback Vy. And after we've applied it, let's handle the friction of it. And we'll say const friction co. And why don't we just set this to 0.95. And how this is going to work is on every update will allow, and you could set this up in a slightly different way depending on how you want to do the multiplication, but I'm going to write this in a way where upon every update we will allow the knockback to retain 95% of its previous value. So let me show you what this looks like. We're going to do if, you know what, actually, because I'm thinking about it, knockback can be in both directions, so we need to handle positive and negative knockback slightly differently. So if it's, here, we'll do knockback movement, knockback Vx. If it's less than 0, we'll set the movement knockback Vx equal to, and let me just make this smaller. We'll just title this F, friction coefficient. We'll set it to F times math ceiling to bring it up to 0. We want to make this go towards 0. Movement knockback Vx. Now, else if movement knockback Vx is greater than 0, we need to floor this value. So knockback Vx is equal to F math floor movement knockback Vx. And then let's do this for y. So movement knockback Vy, if it's less than 0, we need to ceiling it. So movement knockback Vy, math ceiling movement knockback Vy. Then else if movement knockback Vy is greater than 0, movement knockback Vy is equal to math floor movement. And I know I didn't apply the coefficient. I'm going to do that in 1 second. Okay, cool. Cool. Let's do a little checking. I want to see just one more time. Let's go through a hitbox system before we check. Knockback right. Well, actually, if it's, these values must be inversed. This was incorrect because if it's coming from the right, it needs to be pushed to the right. If it's coming from the left, then it needs to be pushed to the left. Okay, let's see how this works. Now, if this works properly, there is going to be a bug that we may need to handle. Okay, push to the right works well. Let's go up. Up works well. Okay. Let's make sure down works properly. Down does work properly. Oh, well, we did have that little bug right there. He's going over those bushes. Now, that was a weird glitch and not the one I was expecting at first, but I do think I know what's wrong. I think pathing becomes messed up when we load the new screen. And when we load new screen, I'm not recreating the graph, I actually created the graph up here in initialize, right? But we need a new graph every single time that there is a new screen, obviously, because pathing depends upon what screen we're on. So let's just go to load screen, and we can just drop this right back into the function. Can even do it right at the very top. At least for now, I think that's okay. And the second weird thing that I noticed was that the entity IDs were much greater than what they should be. So we want to reduce the number of entities back down to 0. And after we do that, let's save it. And we can, let's just check, make sure this is fine. I'll go back in. And let's see, he shouldn't be able to avoid us or to go through collidables now, which it does not appear that he can. Very good. So, okay, that looks like it's fixed. So the initial glitch or the initial bug I wanted to show you was this one right here, where Link is now stuck in the wall. Now we can kind of get out of it, but we don't want him to get stuck into the wall ever. That's not good gameplay. So how are we going to go about fixing this? Now, if we go back to our game, or go back to our code, I should say, we need to make a few changes to two of our key systems, the collision system and the movement system. Now, for the collision system, we're taking into account the movement. However, we're not taking into account the knockback. So that's something that I do want to incorporate in this logic structure. So we'll just do movement, knockback, Vy. And then also we need to consider the collision will be true, yes, if there is X velocity. However, what if Link, just like in our example that I showed you, was standing still? So we need to also incorporate that logic into this logic structure. Movement, knockback, Vy. So that's the first thing that I was thinking about. Now, something else that we need to consider, and game engines tend to use this method in order to reset the entity to its last known position. Now that we're dealing with knockback, I want to be able to reduce the glitchy behavior that we're seeing. So the best method to do this is to keep track of the player's previous X and Y position, and if there is a collision detected, we can just reset the player to the previous value before there was a collision. And we're going to make an adjustment to our position component, and we're going to set it previous X to, we can just set it to X, and this previous Y equal to Y. In our movement system is where we're going to be making the actual change and instituting some logic to help us achieve this kind of outcome. So if we come here, we see that we're handling collision X by just incrementing or decrementing the position based on the direction the entity is facing in. But now let's change it and handle this slightly differently. So let's also set the knockback back to 0 if there is a collision. And we're going to set position X equal to position previous X, right? Just like here. And if there's no collision, then we will update the previous X equal to position X, like that. And now let's do the same for Y. We can delete this. We'll do movement, knockback, Vy is equal to 0. Position Y is equal to position previous Y. Or if there is no collision, we'll just update position previous Y to position dot Y. Now let's test this out and see how it goes. Oh. Of course, my game is a little laggy. I'm by the edge. And if you saw that, you saw that Link bounced against the rock, but he did not get pushed in.